everyone, myself Shravanthi, working as Assistant Professor in Cybersecurity and Data Science in MLR Institute of Technology. Today our topic is DFA with examples. In the last class we have discussed DFA with examples that starts with. Today we are going to see ends with examples. So the first one is, design DFA for the language L which accepts all the strings over alphabet sigma equal to 0, 1 that ending with 0. So it is ending with 0. So we are going to construct a string. So that string should have a string that should end with 0. It should end with 0. So in the last class also we have discussed which starts with. Now today we are going to discuss which ends with. So first what we need to do, we need to construct a language. We need to construct a language over alphabet 0, 1. 0, 1 are the alphabets, nothing but symbols. For the, what is the constraint is the condition, that is ending with 0 is the condition. So let's construct a language. Language is nothing but, it's a collection of strings. String is nothing but symbols, collection of symbols. Okay, so which are ending with 0. So 0, this is one string. So 1, 0, this is another string. See here, the constraint is ending with 0. It should end with 0. See, it is also ending with 0. I cannot write 1, 1. Why? Because here it is not ending with 0. It is ending with 1. So, it is wrong. So, this is not accepted based on this condition. So, the next what I can write 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, 0, 1, 0. So, we can go on. We can write n number of strings. So, what type of language it is? It is a infinite language. It is a infinite language. Why it is infinite language? Because the condition is it is ending with 0. There is no constraint that the language should have only 3 strings or 4 strings. That is not the constraint. But we have a constraint that is ending with 0. So, first we have constructed a language. Then what we need to do? We need to construct a DFA diagram. We need to design DFA diagram. See here, what is the minimum length string here I am having? 0. This is nothing but one length string. So, how many number of states I will have? N plus 1. Nothing but 2 states will be there. So, 2 states. So, let me take the first string and construct. So, Q0. Next, Q1. So, this is 0 and this is my starting state. Q0 is my starting state and Q1 is my final state. Q1 is my final state. So, let me construct a DFA based on this language. That means the DFA should accept all the strings which are constructed over language. So, we are constructing a language based on the condition. Based on the condition. So, the first string 0, it is starting from Q0 and it is reaching to the Q1. It is reaching the Q1. Q0 is my starting state. How we are representing? It with an arrow with no input. Nothing but edge with no input. Q1. Q1 is my final state. How it is represented? With 2 circles. So, see here, the first string is 0. So, the string from Q0, it is moving to Q1. How we are going to say that whether the string is accepted by DFA? If it reaches for final state. It should start from starting state and it should reach the final state. Then we can say that the string is accepted. We can say that the string is accepted. So, the next one what I am having? 1, 0. 1, 0. So, see here how we are going to construct a DFA diagram. 0. So, what I am having the first is 1. So, I can place here 1, 1, 0. 1, 0. Starting from Q0, 1 and it is reaching 0. Nothing but it is reaching the final state. It is accepted. So, let me see here 1, 0. So, what it is? It is starting from Q0. Q0 on 1, it is staying on Q0 and Q0 on 0, it is moving to Q1. See here, how we are going to tell the string is accepted? If it reaches the final state. So, the Q1, it reaches the final state. So, the string is accepted based on my DFA diagram. So the next what I'm having 100. 100. So 100 is nothing but what? 100. 100. 100. 100. So check here how it is accepting. So 10, and if I keep here 0, again it is reaching my final state. It is reaching my final state. So nothing but the string is accepted. 100. It is accepted. See here the next string 00. 0, 0. The string is accepted. This is also accepted. 10, 10. 10, and I have 0. But again what I am having here 1. 1. I cannot place here 10. Okay. I can place, but that constraint is it should end with only 0. It should end with 0. Any number of zeros. Nothing but if I keep here loop, this string, the condition will be accepted. If I place 10, here, instead of taking 0, 1, I can take 0, 1. Instead of 10, I can take 0, 1. 0, 1 is nothing but it is ending with 1. But my condition is it should end with 0. So that is the case. I am not taking here 1. That is the thing. I am not taking here 1. So 0. So next what I am having 10. 10. So it starts from Q0 on self state 1, and I am having 0. It is moving to Q1. It is moving to Q1, and the next I am having 1. So where I should place that 1? I cannot place self loop 1. So I can move to the other state. Let me check it. 1. If I place here 1. 1, 0, 1, 0. It is reaching my final state. So the string is accepted. Let me check it. 1, 0, 1, 0. So Q0 on 1. What it is? On Q0. Q0 on 0. It is moving to Q1. Q1 on 1. Q1 on 1. Where it is going? It is going to Q0. And Q0 on 0. It is moving to Q1. So the string is accepted. How I am telling the string is accepted? It reaches my final state. It reaches my final state. So this is the string is also accepted. Let me check the other string. 0, 1, 0. The string is accepted. So any string you take that should end with 0. The length can be 1, 2, 3, 4, so on. So that's why we are telling it as a infinite language. Okay. So now we can construct the tuples. What are the 5 tuples we are having? So how we construct 5 tuples? So 5 tuples, what are the 5 tuples I am having? The first one is Q, sigma, delta, Q0, F. Q0, F. So these are the 5 tuples I am having. So what is Q0 I am having? Q is nothing but how many number of states I am having? 2 states. So Q0, Q1 are the 2 states, set of states we have written. So the next one is sigma. Sigma is nothing but what are the inputs I am having? 0, 1. 0, 1 are the inputs. What is Q0? Starting state. So Q0, what is the starting state I am having here? Q0. The next F. F is nothing but what is the final state? So final state. What is the final state I am having? Q1 is my final state. Q1 is my final state. So what is the other one I am having? Delta. Nothing but the transition function or the transition table we are going to construct. So how we are going to construct transition table? How many number of states? 2 states. Q0, Q1. It is 0 and it is 1. So the inputs I am taking here are 0 and 1. So Q0 on 0. Where it is going? Q1. Q0 on 1. Where it is going? Staying in the same thing. Q0. Q1 on 0. It is lying in the same. Q1 on 1. It is moving to Q0. So see here all the states are filled. So there are 2 states. These 2 states are having at least one input with the number of input symbols. So that's why we can say that this is a DFA diagram. This is a DFA diagram. Every input should have some path or some transition should be there. So by seeing this transition function or transition table, we can tell that it is having some path for each state. For each input, there is some path. So that's why we are going to tell it as DFA diagram. So it's clear? Let's move to the next one. So the DFA for the language L, which accepts all the strings over alphabet sigma equal to 0, 1 ending with 0, 0. It is ending with 0, 0. So what we need to do, what is the condition I am having? It should end with 0, 0. So 1, 0 should be followed by other 0. 1, 0 should be followed by other 0. The start can be either 0 or 1. Anything can be either 0 or 1. It's a combination of zeros and ones. Any number of multiple times also I can use. But my condition or my constraint is it should have double 0. Nothing but 2 zeros should be there. 1 0 should be followed by other 0 is the condition. Starting can be anything. So this is the condition. Over an alphabet 0, 1. Over an alphabet 0, 1 is the condition. So let's construct a language. First let's construct a language. So let's construct a language. So what is the language we can have? So the first I am taking is 0, 0, 0, 0. So the next I can take it as 1, 0, 0. I cannot take 1, 0, 1, 0. Is this string accepted? No, it is not accepted. Why? Because it is 2 zeros. Here I am having 1 and 0. So 1 is followed by 0. But here last at the end 0 should follow by 0. So 0, 0. Next I can have 1, 0, 1, 0, 0. 1, 0, 1, 0, 0. 3 zeros also can be there. Or else I can have 1, 1, 0, 0. Anything, any string I can have. But that is ending with 0, 0 is the condition. So what type of language it is? It is a infinite language. What type of language it is? It is a infinite language. So first we need to construct a language and check the minimum length. So what is the minimum length string here? 2. So minimum length string is 2. So number of states we will have is n plus 1. Nothing but 3 states will be there. 3 states will be there. So let's construct a DFA diagram. So DFA diagram. So let's plot the 3 states Q0, Q1, Q2. So these are the 3 states I am having. So these are the 3 states I am having. So here the strings which are constructed under language. So those strings I am plotting under DFA diagram. So what is the first string I am having? 0, 0. So let the start state is nothing but the starting state Q0. So the final state I am taking is the last state is my final state. So what is first string? 0, 0. So directly I am plotting 0 and 0. 0 and 0. So 0, 0. So check whether this string is accepted or not. Yes, it is accepted. 0, 0. Q0 on 0. Where it is moving? On Q1. Q1 on 0. Where it is moving? Q2. So nothing but Q2 is my final state. So the string is accepted. So the string is accepted. So the next what I am having? 1, 0, 0. So here what I am having? It is starting with 1. It is starting with 1. So how we are going to construct it? So let's plot here 1. Let's plot here 1. 1, 0, 0. So this string is also accepted. 1, 0, 0 is accepted. So the next what I am having here? 0, 0. Triple zeros can be plotted here. 0, 0. I can place here 0. I can place here 0. Triple zeros, check it here. 0, 0, 0. The string is accepted? Yes, the string is accepted. The string is accepted. So the next what I am having? 1, 1, 0, 0. 1, 1, 0, 0. It is also accepted. So the next what I am having here? So 0. I can also take 1, 0. See here 1, 0, 1, 0, 0. 1, 0. 1. Can I keep here 1 here? Will it work? 1, 0, 1, 0. So instead of that, so what I am doing here? 1, 0. 1, 0, 1, 0, 0. 1, 0, 1, 0, 0. The string is accepted. 1, 0, 1, 0, 0. Let me check here. 1, 0, 1, 0, 0. So Q0 on 1. It is moving to Q0. Q0 on 0. It is moving to Q1. Q1 on 1. It is moving to Q0. Q0 on 0, it is moving to Q1. Q1 on 0, it is moving to Q2. So this string is accepted. This string is accepted. I can place here also 1. No issue. 0, 1, 0, 1, 0, 0. This string is also accepted. So the next one what I am having. So check whether it is satisfying my DFA. Check whether it is satisfying my DFA. So what is the DFA condition? Every state should have the paths. How many inputs are there? That many paths should be there. At least one path should be there. Like Q0. See here, Q0 should have 0 and 1 path. Q1 should have 0 and 1 path. Q2 should have 0 and 1. Some transition should be there, one for one input. See here, Q0 on 0, there is a path. Q0 on 1, there is a path. So Q1 on 0, there is a path. Q1 on 0, there is a path. So coming to Q2, Q2 on 0, there is a path. But there is no path for Q on one input. On one input, there is no path on Q2. So it is not a DFA. This diagram is not a DFA. So we need to convert it into, to make it a DFA. So we need to convert this diagram to make it a DFA. So how we are converting? So for Q2, there is no path for one input, there is no path. For one input, there is no path. So let me check where to plot this 1. Either to Q1 or Q2, or Q0 or Q2. Let me check it. So Q2 on 1. Q2 on 1 is nothing but, so what it happens if I place here Q2 on 1. So how the expression, the string it takes is 0, 0, 0, 1. This string is also accepted. But my condition is that should not have 1. 0 should be followed by 0 only, not 1. So that is the case. That's why we are not keeping here 1. So that is the reason we are not keeping it here 1. So where I am going to do here? So Q2 on. If I keep here 1, 0. So can I plot here? Will it works? Q0 on 0. 0, 0, 1, 0. See here. 0, 0, 1, 0 is plotted. It works. Instead of keeping here 0, I can also keep here also. I can also keep here. See here 0, 0, 1, 0, 0. 0, 0, 1, 0, 0 can also be plotted. So this is nothing but DFA diagram which ends with 0, 0. Which ends with 0, 0. So Q0 is my starting state. Q2 is my final state. Let me check any diagram. It accepts 0, 0, 1, 1, 1, 0. Let me check here whether this is plotted or not. Q0 on 0, it is moving to Q1. Q1 on 0, it is moving to Q2. Q2 on 1, it is moving to Q0. Q0 on 1, it is staying in Q2. Q0 on 0, it is moving to Q1. Q1 on 0, it is moving to Q2. So the string is accepted. So how we are going to tell the string is accepted? If it reaches the final state. If it reaches the final state, then we are going to tell that the string is accepted. So the same way we can construct the 5 tuples. So what is the way to construct the 5 tuples? So Q, sigma, Q0, F, delta. So these are the 5 tuples. What is Q here? Based on this diagram, how many number of states are there? There are 3 states. Q0, Q1, Q2. These are the set of states. Next, sigma. Sigma is nothing but what? What are the input symbols? So 0, 1 are the input symbols. Q0. Q0 is nothing but starting state. What is the starting state? Q0 is my starting state. So what is F? F is nothing but final state. Final state is what? Q2 is my final state. So the next we are having is transition function delta. So see here 0, 1. So what are the states I am having? Q0, Q1, Q2. Q0, Q1, Q2. Q0 on 0, it is moving to Q1. Q0 on 1, it is moving to Q0. Q1 on 0. Q1 on 0, where it is going? Q2. Q1 on 1, it is moving to Q0. So Q2 on 0. Q2 on 0, it is moving to Q0. Q2 on 1, it is moving to Q0. See here, all the things are plotted. All the input symbols are plotted. Only one transitions are there for each state. Only one transitions are there for each state. So this is the ending with 0, 0. Thank you.